values very well. So sine pi on 6 is half. So that would be 1 on root 2. That will be root 3 over 2. 1 on root 2. Root 3 over 2. And then half. And this is 1 root 3. 1 over root 3. Okay, so need to know this very well. Doesn't take that long to learn them. Once you know it, you will know it. Okay, so write them down. Alright, once you write them down, then you can solve some. We also need to remember how to solve some trigonometric equations, which is useful in this topic. So we're going to solve the first one. Tan x equal to -1. So you write x. You look at the quadrant in the second and the fourth quadrant. And then after that, you have to find the x value, find the related angle. So you go related equal to tan inverse of 1, which is pi over 4. So write pi over 4 there, pi over 4 here. So write x equals to pi minus pi over 4 in the second quadrant, pi minus pi over 4, or you can get into the fourth quadrant, which is 2 pi minus pi over 4. And then if you do that, that will be 3 pi over 4, comma 7 pi on 4. Right. Done. Okay, that's good. So we did that. Okay, what do we do after this? We'll do the next one. How do we do the next one? Graph. So just remember, when it's a 1, you draw the graph, and it's going to be at 0 and 2 pi. So this one's very fast, but you just have to remember to do that when you see cos x equal to 1, 0, or -1. Right, these are just a brief introduction, so we need to remind ourselves this important concept from trigonometry, because this will be used again in the inverse trigonometric functions topic. So now we're going to investigate and introduce to you all 3 inverse trigonometric functions. So we're going to go to the next page and then go through how we develop these graphs. So let's look at the next page. All right, so let's look at as you can see from before, the sine function doesn't have an inverse. Why doesn't it have an inverse? Because it is not what? Not a one-to-one function. Very good. You have to use the keyword one-to-one. So it fails the horizontal line test. So if I draw a horizontal line, it will cut more than 1. So it doesn't have an inverse. So for it to have an inverse, you need to restrict the domain. And there's many ways to restrict the domain. The one we're going to choose is the one between negative pi over 2 to pi over 2. So we're going to restrict to this part. Now the function is monotonically increasing, isn't it? So it becomes a one-to-one function. So this part here, if I move it over here, if I draw the inverse, becomes this bit, right? That's an inverse. Oops, becomes straight. Let's try again. Okay, like that. Okay, so it's going to become the inverse. All right, so what do we do? So we're going to draw this again. Now, note that the domain range has been swapped. So we're going to restrict between x between negative pi over 2 and pi over 2. So the restriction on the domain will become the range of the inverse, right? That's the range of the inverse. And before the range of the function becomes the range, becomes the domain of the new function, so between 1 and -1. Okay. All right. And then what we're going to do is to draw the graph again, so we can remember what it looks like. So in the space below, you will see the space for the graph, and the symbol for the sine inverse sine is sine to the power -1. There you see there. That's the one you've seen before, sine inverse of x. That's the inverse function. Okay, let's draw this again. Now remember, domains between -1 and 1, remember that was the range of the original function, becomes the domain. And then the range comes from the domain of the previous function. So it's going to be between y between -pi over 2 and -pi over 2, like that. Okay, so now we're going to draw the graph. So we're going to write x and y, and then we're going to put 1 here, put -1 there. And then what we do here, just remember what pi over 2 is. Now pi is about 3 point something, so pi over 2 is about 1.5. So if I do that on a calculator, you will get 1.5. So it's slightly longer than the domain, isn't it? The range is slightly longer. So what we do, you just make sure you reflect that. So that's 1.5 times 50%, about 50% longer. So you put it here, a bit higher than the 1. So you write pi over 2, and then a bit higher than the -1, negative pi over 2, like that. Okay, so you just label these first, and then what you do is you're going to plot the 3 points, one at the origin, and then one here, and one there. Okay. Now be very careful how you draw it. Let's look at the features. Now, if I draw a line here, that's a stationary point, isn't it? So that means if I draw it this way, it becomes a vertical tangent. So make sure your graph reflect that. Let's use a blue pen, actually green pen here. So let's go like this. So it's like vertical tangent, and it goes towards here. It's an inflection point, but not horizontal point inflection, and then keep going up, and then it's become vertical tangent. So in your graph, make sure it's vertical tangents here, vertical tangents, and the gradient at the 0 it's equal to 1. So we'll show later that the gradient is actually equal to 1. Okay, good. All right, any question? All right, good. So we're going to continue. All right, we need to know how to do some calculation. Now we have drawn the graph with the features shown. Make sure you show that this is, yep, that's the graph going upwards like this. This is the inverse sine functions. Okay. Another thing you need to know is that, need to take note of, is that the angle is in the first and the fourth quadrant. So what that means is that if the ratio is negative, you get the angle in the fourth quadrant. If the ratio is positive, you get the angle in the first quadrant. Okay, so the angle will be restricted to between first and the fourth quadrant. Okay, first and fourth. Okay, so now we can do some calculations. So the calculation can be done in 2 ways, in many ways. Let me show you all the different ways. So for the first question, what we do is we're going to do the first one. So sine inverse of 0, you can just look at the graphs. Sine inverse of 0 is 0, isn't it? So you just write 0. What's another way to do it? Obviously, your calculator can tell you. So make sure it's in radian mode. Shift sine 0. That will also give you 0. So you can either use graph, or use calculator. Okay, how about the second question? Second question, again, you can also use the graph. Sine inverse of -1 is negative pi over 2 from the graph. So you can just write minus pi over 2 if you remember what the graph is. Or using your calculator, what you need to do is you write sine inverse of -1, and then you press equal. Now it doesn't give you pi, isn't it? So what you need to do, you divide that by pi, so you get the exact answer, -½, so it's negative pi over 2. So what you need to do, you have to divide by pi in radian mode, in rad, so you get -½, which means that it's going to be negative pi over 2. Or if you do it in degree mode, so say I do it in degree mode, shift mode, degree, and try this again, you will get -90, and -90 is negative pi on 2. So you can do it in the third way, or you can do it in degree mode, or degree mode, you can just get -90 degree, which you have to convert to radian. So there's 3 different ways you can do. Do it in degree mode, do it in radian mode, or use the graph. Okay, now how about the next one? The next one, you can't really use the graph because half, it's a bit hard. So half is around here, so it's a bit hard to see from the graph. So this way, you can only use your calculator. So you can either do it in degree mode. So you can press half, 1/2. It will give you 30 degrees, which convert to radian. Or you can do it in radian mode, shift mode, press 4, press equal, but you just have to divide by pi. And that gives you the exact answer of pi over 6. So you get pi over 6. Okay? Now, what if it's a negative ratio? The good thing is that your calculator is already have the same range as the inverse sine function. So you don't have to do anything. Just go press shift sign, negative half, negative 0.5. It will give you the correct answer in the correct quadrant. Divide by pi. So you press equal, so you get negative pi over 6. So you get negative pi over 6. So your calculator sine inverse is actually the inverse sine function. So if it's negative, it gives you the angle in the fourth quadrant automatically. And the last one, sine inverse of 0.2, you just have to press 0.2, but that won't have an exact value because if you divide by pi, it doesn't give you an answer. Okay, so so you just do it like that, right? Correct to one decimal place, negative 0.2. Okay, done. All right, any questions? So that's the sine inverse. Then we'll look at the cos inverse, then the tan inverse. Okay, yep. Oh, how do you get 0.2? So if I do that in degree mode, shift mode, 3, give you negative 11.53 degrees. So if you change it to radian, times by shift pi divided by 180, give you the answer in radian. So that's the angle in radian. So if I do it in radian mode, you give me 4. Yeah, so give you that. So that means if I do sine of negative 0.2 radian, it gives me answer 0.2. Yeah, so that's what the answer, that's the angle. Remember, the answer you're getting is now angle. Yeah, does that make sense, or is that what you mean, or? Yeah, okay. It's just a coincidence that they look very close, 0.2, negative 0.2. But if you pick a different number, say 0.4, you'll get get the same. So maybe 8, that could, yeah, all right. All right, good. All right, let's move on. Next one, cos inverse. So again, the cos inverse doesn't have an inverse, so we have to restrict the domain. The way we restrict the domain will be different from sine inverse because if I pick these two, it wouldn't be monotonically increasing, isn't it? It won't be 1 to 1. So what we do is we restrict this part. Okay? Right, restrict to this part, and then which means you get this part here. Right, like this. So that's our restriction. So we restrict between 0 and pi. So let's draw the graph. So draw the graph of cos inverse. So to draw the graph, we're going to write down the domain range. So the domain will be between 1 and negative 1. 1 here, negative 1 there. So write x between negative 1 and 1. And then the range will be between 0 and pi. 0 and pi. And then we can draw the graph again just for extra practice. So that's 1 and negative 1. Pi is about 3, so it's a bit higher than the sine inverse. X and y. In the middle is pi over 2. Now cos inverse, it has to be going downwards. So start from the top left, middle, just get 3 points. Join them up. Remember, it's a vertical tangent. And then go down, and then vertical tangent again. That's your graph. Okay, so you see the cos inverse graph, it's decreasing, it's going downward. But the shape of the cos inverse are very similar to the shape of the sine inverse. One's going upward, this is going downward, above the x-axis. And for this, we need to know that the angles in the cos inverse is only in the first and the fourth in the second quadrant. So if it's negative ratio, you get answer in the second quadrant. And then we'll do some calculation questions. Okay, let's do that. So we're going to do the first one. So the calculation question, when it is on the boundary like 1, 0, and -1, you can just use the graph, or you can use the calculator. Okay? If you use the calculator, you can either do it in degree mode or radian mode. Let's put in degree mode, shift mode, degree. And if you do shift cos 1, it should give you 0 degrees or 0 radian. But cos inverse of 0, you will get 90 degrees, which is pi over 2, like that. Or you can just get the point here, pi on 2, at x equal to 0. And -1 will be pi. So you can do it on the calculator. -1, you get pi. 180, you get pi. Okay. And then what if it's half? Half is 60 degrees. You can check on the calculator. 60.5. So you get 60 degrees, which is pi over 3. So 60 degrees, so you get pi over 3. And what if it's negative? It will give you the answer in the second quadrant. So check. So if you put a negative there, it automatically give you an answer in the second quadrant. 120 degrees plus 120, it's 2 pi over 3. Okay, in the second quadrant. Second quadrant. Okay, good. So after that, we're done. Then we just have to do the tan inverse. Okay. All right. Any question before we continue? All right. Flip over. Then you get the tan inverse. Have a think. All right, good. Let's go to tan inverse. All right, with the tan inverse, again, it doesn't have an inverse, so we restrict the domain. The way we restrict the domain is exactly same as the way we restrict the sine graph. So we're going to restrict between negative pi over 2 and pi over 2. So we're going to just take this part here and reflect it around this line. Okay, like that. Reflect this about the line y equal to x, so which you will get this graph. Okay, so we're going to restrict between negative pi over 2 and pi over 2. Alright, so restrict between this. But it won't be equal to negative pi over 2 because it's not defined at negative pi over 2. So we'll restrict between negative pi over 2 and pi over 2. Alright, well let's draw this. When we draw this, we're going to write down the domain. The domain is actually all real x. And the range is between, just use that, negative pi over 2 and pi over 2. Okay, so for the tan inverse graph, it has got a horizontal tangent. So if I put negative pi over horizontal asymptote, so it has a 2 pair of horizontal asymptotes. So put a dotted line here, dotted line there, put an x, put a y, and then what you should do is note that when tan inverse of y is pi over 4, so this is pi on 4, pass through this point here, and then you draw the graph like this. Okay, like that. Right, that's the tan inverse graph. All graphs should be remembered, should be memorized, because you will be asked to draw them in the exam. It's more likely you will get a graph of sine inverse or cos inverse. Less likely you'll get one on tan inverse. Alright, so what do? We can then do the questions. Yeah, let's do this. You could do it with the calculator or without a calculator. So to do the first one, tan inverse of y, you can do it in degree mode, change to radian. I think that could be more convenient. So just press shift tan 1, you get 45 degree convert to radian, pi over 4. Okay, so you need to know your exact, all your exact ratios. So that's pi over 4. And 0, you can just look at the graph. 0 is at 0. -1, you get negative pi over 4. So it's going to be in the first and the fourth quadrant. If it's in the fourth quadrant, the angle will be negative. And tan inverse root 3 is 60 degrees. And that will be pi over 3. That will be negative pi over 3 if it's negative. Okay. So if it's negative, you get pi over 3. Negative. Okay. Right, done. Alright, good. Any question? Alright, all done? Okay, so after we finish, we can now, let's review all 3 graphs on the next page. You can now summarize all 3 information. See if you can remember, take a few minutes to fill this out, write in domain range and draw the graph. I think could be on the master map, these graphs. Are they on the master map? I could see sine, cos, just the inverse. Or you can just do it inverse. Yeah, you just flip it. Yeah, just flip it. Yeah, that's good. All right. Okay, so do this. So have a look at your graph and draw them on the next page. All right, there's space for you to draw. Do this now. So start with the domain. And the range is between minus pi on 2 and pi on 2. And put x and y, x, y, x, y. All right, take a minute to finish them. Again. Okay, good. So let's see. So we got minus pi over 2. Remember, the range on the y-axis is slightly longer than the domain. So when you draw the graph, make sure you do that. Put 3 points. 1, 2, 3. Vertical tangent. Concave down, then concave up. Vertical tangent. So it's very steep. It's a vertical tangent there. Right, next is cos inverse. My y is in the way, so let's put it on the other side. 1, -1, 0, pi here. This is pi over 2. Dot, dot, dot. It's going downwards, down like this, and then concave down. Right? Now you can now compare the sine inverse and the cos inverse side by side. They'll have the same shape, isn't it? Except one's going downward, one's going upward, with different range but with the same domain. Okay, next we're going to look at the tan inverse graph, which have a horizontal asymptote at pi over 2. I think I forgot to write down the domain and range for that. Let's do that. I should have done that first. And this is y between 0 and pi. And the tan inverse, the range it's not equal to pi on 2. It doesn't reach there due to the asymptote. And for the domain, it's all real x. So we do that. So we get negative pi over 2. Horizontal asymptote. Go like this. Very nice. 0. And remember, when x equal to 1, you reach exactly halfway, pi over 4. Right? Okay, you should indicate that point because that will make your graph look better and it's more accurate. Okay, after we finish all of this, you should. It is recommended that you do that a few times at home. You need to memorize the graph. So if you feel that you still haven't memorized the graph, make sure you draw them again a few times and you get better at drawing them. Okay, now we have to do some calculations. Page 6, and then we'll do page 7. Then you can do the work from the booklet I gave you. So go to the next page. All right, if you haven't finished, just finish it later by yourself. All right, so let's look at the calculation questions involving inverse trigonometric functions. All right, let's do the first part, tan inverse of -half. So all you have to do is just press the button on your calculator, shift cos, -half, 0.5. So that will be 120, so 2 pi over 3. So write tan 2 pi over 3, like this. So you just convert 120 degree to 2 pi over 3. And what's tan 2 pi over 3 in the second quadrant with the related angle pi over 3? So the answer will be, in the second quadrant, is negative tan pi over 3. This is 2 pi over 3. And then what do you get? You get minus root 3 is your answer. Okay? Alright, try the next one. So you just calculate what's inside, then calculate what's outside. Try the next one. Alright, next one. What's tan 3 pi over 4? You can do it on a calculator. I think that gives you an exact answer. So tan, oops. Okay, so just go tan 3 pi over 4. Yep. Actually, I could skip that. Let me show you how to do that. So you can go 3 pi and then over 4. But you can put radian on your calculator. So even though in degree mode, you can just go like this. Go to 2. Press equal, give you negative 1. So you go sine inverse of negative 1. And if you remember the graph, let's go through the graph again. The graph looks like this. So now negative 1, it's at minus pi over 2. So you know it's going to be negative pi over 2. Or you can use your calculator. Or calculator. Alright, so it's all pretty easy. Okay, after we finish that, can you take a minute or two filling out the bottom? Again, it's a revision of all the compound angle formula and double angle formula. So fill this out. We'll use that again in the question below. Okay, so let's do them. So the first one, sine A cos B plus cos A sine B, right? And fill the rest of these. The more you do it, the better you become. Alright, let's do more. I think I could rub this off to write a bit smaller so it fits. Okay, let's try this again. Sine A cos B plus cos A sine B. This one is cos A cos B minus sine A sine B. So it's all the formula is AB, but with the sine and cos swapped. And the next one is tan A plus tan B over 1 minus tan A tan B. And I could just go copy and paste and just change a few things. Alright. B, put it here, it will fit nicely. And then all you have to do is to use another pen. This become plus, this become plus, and the other one become minus. Okay, so you need to know that the two formulas are very similar. Actually, I make this full plus. Okay, done. So you need to know this very well. This will be important. And then you got the double angle formula. So 2 sine A cos B cos A. This will be 2 tan A minus 1 over 1 minus tan square A. And cos 2A is a bit special. We have 3 different versions. Oh. So you get sine square, sine square A. Or you can do 2 cos square A minus 1. We just use them in the integration topic. So it's a good revision. Okay, we're not going to use all of it, but we'll use some of it in the exercise below. Okay, let's do some questions. So we'll do some questions. So let's go to, let's do this. Now, normally when you see that, maybe we can just press the button on your calculator. So if you just press Shift hand, I have to put it in radian mode. Radian mode, so you go press this. 4 equal. Radian mode, you have to do Shift tan. Yep. Fraction square root of 5 over 7. Now, if you do that, divide by pi, it doesn't give you an exact answer. Right? So if I do this, it doesn't give you an exact answer. So what you do is, for this one, you have to draw a triangle. So what we do is, we're going to let theta equal to tan inverse of root 5 over 7, like that. And then write tan theta equal to root 5 over 7. Now why do I do this? Because now the question will now become equal to cos theta, because this is theta now, isn't it? Right? This is theta. So I need to work out what cos theta equal to. To do that, all you have to do is to draw a right angle triangle with the theta, with root 5 opposite over adjacent, and the hypotenuse can be found using Pythagoras. 49 plus 5 is 54, so it's root 54. Okay? So therefore, if I want to find the value of cos theta, which I will continue, so this thing is just cos theta, which is equal to adjacent over hypotenuse. Like that. You might like to simplify the third, so root 54, could use that trick. So write 54, press equal, press shift, no, fact. So you get 9 times 6, so 3 root 6. So you get 3 root 6. Yeah, so you can leave it answer like that. Okay? So sometimes where you can get the exact value like the one above, right? Sine cos inverse negative half gives you the exact angle. But when it doesn't, you have to draw a triangle. Okay? But you can also solve the above using triangle as well. It also works. You could try later by yourself. You can draw a right angle triangle. It'll work. And how to do the next one? Exactly the same as before. Have a try. Alright, have a try. So what do? So when you have this inside the angle, you just say let theta equal to sine inverse of negative 1 on 5. So therefore sine theta equal to negative 1 over 5. And then what do we do after this? You have to draw a right angle triangle. Just ignore the negative first. So you write opposite over hypotenuse. Using Pythagoras, you get 25 minus 1 is root 24, which is 2 root 6. Okay, so now the question becomes tan theta, because this is theta now, right? That's what we let theta. And then tan theta is opposite of adjacent, so you write 1 over root 24. Actually, root over 2 root 6. 2 root 6. 1 over this. But remember, this is negative. What quadrant would theta going to be if it's negative? Well, it either be 3 and 4, but be careful, this is inverse sine. It can only be in the first or fourth, but which one would it be, first or fourth? Fourth, because it is negative. It can't be in the third. So therefore, because it's fourth, tan is negative in the fourth, so that one. Had it been third quadrant, that would have been positive, isn't it? But it won't be, because it's an inverse sine function, can only be in the first or the fourth, not anything, not anywhere else. Alright, good. So once we do that, we can just go to the next page, do some harder ones, then you can do the exercise. Alright, all finished? Done. Let's move on next page. Our next page involves the compound angle formula. So what you do is, we call the first one alpha, sine inverse of 3 over 5. Call this one beta, sine inverse of 12 over 13. So the question becomes sine alpha plus beta, which we will expand later on. But first, let's write it as sine alpha equal to 3 over 5. The other one as sine beta as 12 over 13. And then you draw a right angle triangle for both. Right? So you get alpha here, beta there. And then you get 3 over 5, 12 over 13. And then use Pythagoras. If you know your triads well, that will be 4. That will be 5. Okay, of course the diagram not to scale. Okay, now what do we do with the triangles? Once we drew the triangle, we can now expand this. Alright, let's expand this. So we're going to use different color pens. Sine alpha plus beta equal to sine alpha cos beta plus cos alpha sine beta. Which means I could use this triangle to help me. So let's use these triangles. So the triangle will be sine alpha is 3 over 5. Cos beta is 5 over 13. Is that right? Maybe. Cos alpha, yeah, I think it's right. Plus cos alpha is 4 over 5. Sine beta is 12 over 13. Cos beta 5 over 13. Sine alpha is 3 over 5. Yeah, okay, good. So what we're going to do is, you can just times and make a common denominator. 5 times 13 is 12 plus 1, 65, isn't it? 15 plus 48, which is equal to 63. So you get 63 over 65. Right, so you can get that. Alright, so show you, these are the working. I'll try the next one is exactly the same. Very similar, use the double angle formula. Alright, good. So the next one you do the same thing. Let this be theta, not with the 2. So let this be theta, cos 2 theta, because that theta equal to sine inverse of 4 over 5. And then you just work out sine theta equal to 4 over 5. Now in this one, you don't need to draw a triangle. Why don't we need to draw a triangle? Now if we look at this, cos 2 theta, we're going to expand it. Which one will be useful? There's 3 versions. There's the cos square minus sine square. There's the 2 cos square theta minus 1, and the 1 minus 2 sine square theta. Which one would be appropriate? We have sine, right? It would be better if you just use this, because you don't need to draw a triangle that's given to you, right? So you write 1 minus 2, 4 over 5 square. Had you used the cos square, you have to draw a triangle, work out the missing side, then find a cos ratio. But you don't have to do that. You can express this thing in terms of sine, and then you can just substitute. So, and then using your calculator, you will get 1 minus 2 times, well no, 4 over 5 is 0.8, easier to type without typing fraction. Press this, negative 7 over 25. It's negative because it's in the second quadrant. Because when you double the angle becomes obtuse, so cos over obtuse angle, you get a negative answer. I'll just do one more. The other one, I'll just leave it to you to think about. Right, hopefully you're finished. Let's do one more. I will skip E. I think you can do E by yourself, but I'm just going to do F with you. So what if they don't give you anything? Well, what you just do is you just write, let this be alpha. Let alpha equal to this. You still do the alpha and beta thing, but except you have to do one extra step. So let's do this first. Right? So you just write tan alpha is 2 over root 3. Tan beta equal to 3 over 2 root 3. And then what you do is this. So this is now become alpha minus beta. So we're going to work out what this equal to. Because this is alpha, that's beta. So to work out what that equal to, you just say, consider working out what tan alpha minus beta. Because tan are related. And then you just have to expand this. Tan alpha minus tan beta over 1 plus tan alpha tan beta. Just work out what this first, and then that will help you to work out the difference in the angle. So tan alpha is already found, 2 over root 3 minus 3 over 2 root 3 over 1 plus 2 root 3 times by 3 over 2 root 3. And then you can cancel things. Root 3 gets, actually these two cancel. 2 get cancelled. So you end up getting 2 at the bottom. The top, you just have to make it the common denominator. 2 here, that will be 4. 4 minus 3 is 1. 1 over 2 root 3. Like that. And if you simplify further, you get, I may have made a mistake. I've done the work. Plus. Oh, maybe it's deliberate. I forgot. Okay, anyway. So you get equal to 1 over 4 root 3. Alright. Okay, so what you get is, therefore, tan of alpha plus alpha minus beta equal to 1 over 4 root 3. So therefore, alpha minus beta equals to tan inverse of 1 over 4 root 3. So what I think the intention of the question is, that means tan inverse of 2 over root 3 minus tan inverse of 3 over 2 root 3 gives you tan inverse of 1 over 4 root 3. Right, that's done. Alright, good. So that's all. So I think I'll just leave that one for you to try by yourself. And then you can do the exercise 1b today. Tomorrow you do the graph. Tomorrow we'll do the graph and then we'll do more. Okay, good. Alright, all finished. So I'll just make this a bit bigger so you can all see. Yep.